customers to comment on the service at different local businesses and record their wait times. Brenda chooses 12 customers at random for each garage. The wait times for each garage are shown.
Okay. Create a box and whisker plot for each data set. Let's divide and conquer. These 3 tables, you're going to put into one of your lists, quick change. Back tables, you're going to put into one of your lists, speedy oil. Once you do that, we need you to get to the statistics or stat calc button and find the min, max, median, Q1, Q3. Okay, but use your calculator to help you out there. Clear, stat, enter, clear down. If you're having trouble clearing lists, here's what you do. You go and you have to use the up button to get so that the name of the list is highlighted. You push clear and then you push the down arrow or enter to get rid of the list. Don't push delete or it takes the whole list away, and then I know how to re-put it back in, but you get to the top, you push clear, and then you push enter or the down arrow. Okay, so I think I'll do quick change. Make sure you're all taking turns at all of this, like adding the data in, because on test day, you don't have your buddy doing it for you. So make sure it's not always the same person. Okay, I've got a set of data in my list. Stat, go to calc, one variable statistics. Folks, take a look up here a minute. Once you're into the one variable statistics, it is important to check, is it looking at the right list? I put this info in list 1, so I need to change that because it says list 2. The way you change the list number is you push second to get the blue features, and then you look down at the bottom of the calculator. In blue, you can see list 1, list 2, list 3, and so on. So to get back to change that to list 1, I'm going to push 1, and then see what's happened right here. It's going to use my list 1 data. If you're not on the right list, you'll get different numbers or an error message. All right, so know what list you put your data in, and then double check before you find the stats that you're in the right list. Okay, so enter. There we go. Again, we were looking for the 5-number summary that we need for a, what do we call that? Box and whisker. And here's what I have. So, what do we see as the smallest number? What do we see as the biggest number? 5's the smallest. What's 85's the biggest? Do we have enough marks there to go by 5s? That'd be 10, 20, 30, 40. No. So these have to be 10s, huh? Okay, so this is 0. Okay, a lot of times finding the right scale to use is tricky, but at the very beginning, smallest number, biggest number, and since we're doing 2 plots here, you got to look at both data sets. All right, so I have information for quick change, and you guys have information for quick change. So I'm going to put quick over to the side and speedy. Okay, quick change. What are the 5 numbers that we need? Somebody off of one of these 3 tables. Thank you, Myra.
What?
Well, why don't you start with the min? Great. Q1.
Yeah,
15.
15, so that's going to be between 10 and 20. I have to estimate with my eyeball. Median,
19.
okay, a little over from 20. What else?
Q3 is 22.
22, so this is 25. 22 is right about there. And max, 60 is way over here. Those are the 5-number summary for quick change, box, line, whisker, whisker. Speedy oil, back tables. What is the 5-number summary?
Okay, so the min is 5.
Got it?
Q1 is 28.
28 is going to be over close to 30. Thank you.
The median for middle is 36.
Okay, here's 35. The 36 is a little farther to the right.
And then Q3 is 50. And then max is 85.
And 85 will be between 80 and 90. Already off the bat, I can tell that's kind of like that football game problem where this Speedy has a bigger spread. Okay. Interesting. Now, calculate and interpret the IQR for each data set. Who remembers from 2 days ago before the board meeting? What was that IQR?
It was Q3 minus Q1.
Q3 minus Q1, or the distance from here to here on that box, the distance from here to here on that box. So I'm going to go up here, and I've got to do 2 calculations. One for quick, and one for speedy. Okay, and again, what we're doing is Q3's take away Q1. We want to find out how far apart are they. What's the difference between them? In quick, it's going to be 22.5 minus 15. And in speedy, was that 50 minus 20 or 16? What was the 50 minus, what's Q1? 28. Okay. So let's see, 20, 20, you got it already? What is it? 7.5. And then this one is going to be, thank you. That's the IQR. IQR. IQR stands for interquartile range. The middle. Interquartile means middle quarters. Okay. Describe each data distribution and explain. Oh, wait. We need to calculate and interpret. So far we calculated. What does a 7.5 mean compared to a 22? Yes, Jerry.
Is that a small range of numbers?
Quick has a smaller range of, now they're numbers, and what are those numbers for? Minutes for wait time. Is this wait time for the oil tank? Smaller range of wait time minutes. So they don't have to wait as long. Speedy, if they have a large range, that means some people are getting done quick, but some people have to sit and sit and sit and sit. It all depends on the day when you drive up, whether you're getting in quick. Describe the data distribution and explain its meaning. So let's look. That's where we decide, is it symmetric or skewed? What do we see? Skewed right and sort of symmetric. This has a little bit of a skew, but way more symmetric. These two whiskers are closer to the same size than this one. So QuickTime has a couple of people who had to wait a long time, but the majority really did get in pretty quick. Speedy, on the other hand, it's kind of all spread out. Okay, it's kind of all spread out. All right, so quick is skewed, right? And speedy is pretty symmetric. The other thing that I'd say here is this is a wide spread. I'm sure that has a more precise wording that we're supposed to use in statistics, but I think that's important to note. Are all these numbers really telling you something if everything's spread out so much? You know, when it's close together, then you can look for patterns. Identify the measure of central tendency best represent each data set. Now remember, mean and median. Mean and median, we decided which one would be best to use to show what the majority is. And one of them we're supposed to use if things are skewed. Who remembers what's better to use if there's a skew?
Median.
Median. Why?
Because if there's a large number, then that'll change the whole average.
The average gets thrown off by things way far off. So let's see. So for QuickTime, we just said it's skewed. Use median because numbers are skewed. And speedy, use mean since it's symmetric. Mean gives you a more precise middle number. It's an average if you have numbers that cluster around that average, but it can get pulled off when you have skews. Identify any others in the data set, any other measures of central tendency. Excuse me? Outliers. What do we see as outliers? Now, outliers you're probably more going to have with this QuickTime where you have a big skew. What would you say is an outlier for QuickTime? Okay, so for QuickTime, $60 is an outlier. And for speedy, 85 is an outlier. Now the last time we were together, they showed us something, a little 1.5 blah 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 to use. I wonder if they're going to make us do that. What was that? Lower fence and upper fence? Let's flip the page and see whether we need to go ahead and use that. Okay, let's be more precise. Should we be more precise on our outliers? Because we are going to remove outliers and take a look at things. So, flipping on back to Wednesday's work. Okay, remember, I know this is probably foggy a little bit, but we did this thing where we found a certain distance. This is called the interquartile range, and then we found a certain distance below and above the interquartile range. And we did that by taking the IQR, timesing it by 1.5. And then on the bottom end, we subtract down by whatever that number is, and on the top end we add up. So again, let's take a look at this data. Okay, we just said that our IQR for quick, IQR is 7.5. IQR equals 7.5. Now if we take that and times it by 1.5, we're going to get the distance that we're supposed to go down for the lower fence and up for the upper fence. Somebody with a calculator, take 7.5 and multiply it for us. And Speedy, we said its IQR was 22. We're going to times that by 1.5. And we're going to see, we used our eyeballs to find our outliers, but this is how mathematically you do it. 7.5 times 1.5. Did somebody get that? Thank you. And IQR is 22 times 1.5.
33.
All right. So what that means is outliers are 11.25 off either left or right for quick and 33 off for speedy. Okay, so let's see where's the best spot to find that. Right here, this number was, okay, what's the Q1 for quick? 15. And if we go less than 15 by, so now we got to figure out lower fence. You go 15, and then you go down 11.25, or you subtract it. So, excuse me? 3.75. Do we have anything smaller than 3.75? No. And then we did know that there was probably an outlier this way. So the top, Q3, was 22.5. If we add that 11.25, that's going to be in the 33 range, 34. Do we have any numbers bigger than 34? 34 is going to be about here if you're looking at it graphically. Yeah, what number? 60. So in quick, we just mathematically figured out that 60 is an outlier. You guys right now, I want you to figure out what's the lower fence, what's the upper fence mathematically. We gave you a hint. It's going to be 33 this way and 33 that way, but you need to look at Q1, I think that was 28, and Q3, that was 50 on the nose, and go ahead and find the boundaries. What's an outlier? I'm going to walk around.